Yes, dear friends, good evening to everyone. Myself, Prakash Mahalingam, Technical Director of RASE Technical Training Center. On behalf of RASE Technical Training Center India, I warmly welcome you all today free webinar on introductions to subsurface wellhead system and upstream operations. We are truly delighted to have participants from across the regions, industries, and experiences levels. Thank you for joining us. And these sessions is specially designed for like rotational job seekers looking for onshore and offshore opportunities, and then the field professionals aiming to advance their um, careers in the upstream and oil and gas sector. So before we begin, a few points. Just please keep your microphones muted throughout the session, and just feel free to use the chat box for your any questions. We will take them during the question and answer sessions at the end of the session. And this session is being recorded, and it will be shared in our official YouTube channel. Now, I'm honored to introduce our esteemed speaker, Mr. CIJU sir, our training and development advisor, and to give us a brief introductions to today's sessions and the objectives of our training initiatives here at the RASE Technical Training Center. Mr. CIJU sir, it is over to you.
Good evening to all of you. Thank you, Prakash, for the introduction. And I would like to thank everybody to join for this webinar. This webinar is basically organized to have some idea about the wellhead activities and the wellhead works. Basically, it's into the oil and gas sector. I've been working in this sector, oil and gas sector, for the past 30 years, and you know, the lot of activities going on in the sector. Basically, you are going to learn more technically about the wells. Okay, wells, well hookups, and well related well maintenance activities, which will be like discussed in the coming slides by Mr. My friend BINU. Okay, so I'm just going to cover the area where we have the basically what are the issues what we are going to have in the wellhead services. Okay, so can you please just go ahead with the other slides? Yeah. So yeah, go ahead, Ernest. Yeah. Regarding RASE Technical Training Center, you may be aware of the training provided by RASE Technical. It's one of the best training being provided by RASE on practical aspects as well as the theoretical aspects. Okay, so you're going to have an introduction about the surface wellhead system and the upstream operation, and you can learn, the upstream system. So the webinar is going to cover the importance of process safety, one of the big, very important aspects of the training, because the area where we are going to work is highly hazardous, and we should know the process safety requirements, basically with any industry where you're working. Okay, so the introduction of upstream sector as well as the basic overview of well construction and wellhead installations, understanding the importance of wellhead integrity and maintenance, upstream flow basis, journey from wellhead to gathering stations, field-based jobs and rotational openings and oil field operation, smart training and smarter career moves. This all will be discussed in the upcoming sessions. Okay, basically, I'm going to cover about the importance of process safety. Process safety. Why safety is important in oil and gas sector? So one of the questions being asked by everybody. Because see, we all know that every industry requires to have the safety, culture. But here in oil and gas industry, it is one of the highly hazardous area where we have a lot of risk involved in our activities or in our job. Okay, so we always say safety first, because our main aim is to protect the people, protect the equipment, protect the environment which we are working. When we work in the oil field, process safety considers like it's focusing on preventing accidents. The basic motto is to prevent accidents and ensuring safe operations in the oil and gas production. And it involves managing risk related to the operation. And because a lot of toxic gases, high pressure systems, and we have flammable materials, highly flammable materials and equipments. And the key measures we are going to include proper design, system design, regular maintenance, safety trainings, and effective emergency response plans. These are the controls what we have in place to, for the hazards what we are going to encounter during our operation in the oil and gas sector. Okay, and by prioritizing process safety, oil field operations can minimize the risk, protect the person, and maintain efficient and reliable production. Our ultimate is to produce oil. So, but our aim is also to protect the people and the environment. Yeah, please go ahead. Next slide, please. Yeah, HSC. So most of the people may be aware of the HSC. What HSC stands for: Health, Safety, and Environment. So always the aim of HSC is to, the first thing is the people, because human life is more valuable than anything. Okay, next, it's a concerns are essential in oil field operation, and common risk including toxic gases like S2S. S2S, nothing but hydrogen sulfide. Very highly toxic gases which can kill a person within 3 to 5 minutes if it's not controlled. But every oil field, they have a system in place. So the incidents are very rare if you take all the controls and all control measures are in place. The common other hazards like high pressure failures, like the release of pressure valves and the fire hazards, because most of these gases, it like sulfur dioxide, and it can cause fire as well as explosions. Then oil spillage, which is an environmental issue, and because the spillage can cause the affect flora and fauna, and ultimately the environment is affected. So these risks can be reduced by the PPEs. Normally we consider in safety, we consider PPE at the last. But especially when you're encountered with the S2S gases and all, PPE is the first control what you have. The following safety protocols, regular trainings, and using gas detectors, emergency response in case there is a release of S2S gas, how to escape from there. All this, there are procedures and guidelines and specifications in place. And there is a strong focus on HSC ensures safe and responsible operation. Our ultimate aim is the safe operation. Okay, because we need to produce oil, but whereas we have to see the safety of the people working in the oil field. Okay, yeah, go ahead, please. Next slide. Yeah. So we always say that hydrogen sulfide, hydrogen sulfide, S2S gas, we commonly call it as S2S, highly toxic and flammable gas. And normally in the well side, you can find this, it get released from the flange joints and the wellheads, and it's making it a major safety concern for the people working around it. So, but there are like we have personal monitors, we have multi-gas monitor to detect the hydrogen sulfide gas when it is released. So we can escape from the area. We have emergency procedures. So we can use the SCABA, self-contained breathing apparatus, on rescue kits to escape when we are working in a highly hazardous area. So there are control measures, so nothing to worry about it. Okay, every industry has got its own, hazardous or risk, but if it is well controlled, if it is within the control, everything will be safe. Okay, go ahead, please. Next slide, please. Yeah. So key safety barriers in wellhead and field operations are emergency shutdown system, ESD. Okay, so it stops production automatically during high pressure leaks or fire to protect the people and equipment. So everything is controlled. So there's a control of any sudden release of pressure. Okay, then pressure relief system, safety releases, excess pressure can be released. Okay, to avoid damages to the equipment and accidents. And gas detection system, continuously monitoring the hazardous gases like S2S, sulfur dioxide, propane, methane, and all toxic and the explosive gases can be detected. And fire and gas detection system is also there to detect so early warning can be given and to evacuate the area. Okay, so there'll be an alarm, especially when you're working. If there is a leakage, and blowdown systems quickly venting the gases and reduce pressure during emergencies. Sand detection system, identify sand production early to avoid damage to wellhead and surface equipments. It's all part of the maintenance. Okay, so let's go ahead. Yeah, next slide, please. Yeah, now regarding the safety aspect, health and safety environmental requirements, it's the must subject. When you start, learning, you will have to cover those specific areas where the hazards are more. So we'll be discussing in the future classes, the trainings, and we'll be given proper training how to deal with those hazards and risks. Now I welcome Mr. BINU KRISHNAN, who is a well-experienced person. I know him for the past 18 to 20 years, working in the oil and gas sector, and presently working in he's a specialist in wellhead and he's a lead trainer as well as for the surface wellhead and pressure control equipment. So he can give you more technical informations about the wellhead and maintenance and pressure control equipments. So anything regarding the technical information, you can discuss with him. And over to BINU. Thank you very much.
Sir, thanks a lot for your wonderful insights. Sir, from the comments, there is one question from Mr. Noor Alam. So he's asking about what is the LEL level for H2S on the wellhead area.
Wellhead area?
Yeah.
We have lower explosive as well as HCl also, high explosive also. Okay. So every gas has its own LEL and HCl, UEL, upper limit. Okay. So the explosion can happen when it reaches the upper limit. LEL means lower explosion. When it reaches the lower hello.
Okay,
hello.
Sir.
Every gas has its own characteristics. Okay. So different gases like propane has got different LEL, methane has got different LEL. So it's a different subject. We need to have discuss on this specific gases.
Okay, sir. Thanks a lot for your wonderful answer, and thank you so much, Mr. CIJU, sir, for that insightful introductions and for that sharing the inspiring visions behind our training initiatives at the RASE Technical Training Center. We deeply appreciate your dedications to creating a learning environment and that's foster growth, innovation, and excellence. Your passion for education and your consistent support for both faculty and students are truly commendable. And thanks a lot once again.
Thank
now,
you. Thank you very much.
Further delay, without further delay, it's my pleasure to once again welcome our speaker today's sessions, Mr. BINU KRISHNAN. And BINU is a wellhead specialist and a lead trainer with a vast experience in the surface wellhead systems and upcoming upstream operations over the year and year, almost 25 years of experiences in this wellhead. And he has trained hundreds of engineers and technicians over the entire period of these 25 years. And today is going to guide us to the core concept of surface wellhead systems, and is going to provide a clear understanding of how they integrate into the broader upstream oil and gas operations. Mr. BINU, the stage is yours.
BINU, you're on mute. Please unmute.
Thank you, Prakash. Good evening, everyone, and welcome to the session. And thank you, Mr. CIJU, for your helpful and supportable information about process safety. And I'm BINU KRISHNAN. I'm a wellhead specialist, almost 27 years over in upstream oil and gas sector. Today, I'm very happy to guide you through the basic of wellhead systems and upstream operations. And also I will share some job opportunities, informations, and training benefits. So let's begin our session now.
Mr. Sorry for the interrupt. Mr. Admin, just could you please switch over the camera? Okay, I think some technical error. No issues. Sorry for the interrupt. Mr. BINU, please go ahead.
Thank you, Prakash. So we will start our session now. Introduction to upstream sector. I think most of them heard about upstream. So we will come to the session. The oil and gas industry is divided into three main sectors: upstream, midstream, and downstream. Upstream mainly focus on exploration and production. Midstream, storage and transportation. Downstream, refining and marketing. These are the three sections and sectors. So today we are focusing on upstream operation, exploration and production. So midstream and downstream we will not touch today. So basically the activities in the upstream sector, the basic activities, the below are the main activities. See the activities, the first activity is exploration. It's the responsibility for finding the oil and gas. The company search for underground oil or gas, the using for seismic surveys, using sound waves to scan the earth, satellite and geological survey and data. Then we will do the exploration well, like a test well, to confirm the reservoir pressure and pressure. Thereafter, we are going to the next stage for drilling, making a way to the reach to oil and gas. The drilling is the second stage for our upstream sector. After the confirmation, from the reservoir confirmation means for exploration confirmation, drilling rigs are used to create a well deep into the ground. This is the activity for the drilling. The type of, there are many types of drillings. Vertical drilling, that means straight down. Directional drilling to reach hard to angle targets. The area we are finding some struggling to the reach to the reservoir, the calling directional drilling. And the most advanced drilling is a horizontal drilling to cover more area in the reservoir. Is the highly high-tech and scientific drilling. So that the third stage, the well construction and completion. Once we started the drilling along with the construction, well construction and drilling will conduct. That means the main core aim for the preparing the well. So we confirm the exploration stage, then we started the drilling, then the construction will start with the completion. So once the drilling is done, the drilling they started and done, the casing pipe are installed to the support the well. The casing pipe are installed to support the well. The cementing is done for safety and pressure isolation, also the strength of the casing. And the wellhead and Christmas tree are installed at the surface as a pressure control equipment. It's a completion equipment. Tubing and downhole equipment are placed for the oil flow. It's also considered as a pressure control equipments. Then we complete our well construction. We will hand over to production stage. So beginning oil and gas to the surface. The oil and gas flow from the reservoir to the well bore. In natural pressure is not enough, so we will use some artificial lifting system like a beam pumps, sucker rod pumps, gas lifting, oil or other ESP pumping system. These are we will use for the artificial lifting system. For if there is a natural pressure is not enough to flow from the reservoir to the well bore. The flow is controlled using valves, chokes, and sensors. Is all flow control and pressure control devices and equipments and components. So the next stage after the production, during the production, we have a handling and transporting system. So there's a surface handling and transporting. This is a main upstream operations. So the produced oil and gas and water go through. There's a flow line like a pipeline. It's calling flow line. It's a terminology in oil and gas. Upstream operation, oil field operation, flow lines. The flow lines will connect it to the wellhead. So from wellhead to the flow line will transport your oil and gas to the next point is called manifold. Manifold means the combining flow from different wells. It's different wells is coming to the manifold. The manifold is thereafter, once you reach to the manifold, thereafter there is again flow line will connect from manifold to the group gathering station. There is a separation system. There is many kind of equipments they placed over there for the separating oil, gas, and water. This is the surface handling and transporting in upstream operation. For this all activity, we need a control and monitoring system. So monitoring, maintenance, and safety control system. Field and control rooms, this is calling central control rooms, the CCR. There are check equipment regularly, pressure, their responsibility for pressure, temperature, leaks to check regularly. Also, wellhead integrity test for the maintenance part. Also, do the preventive and corrective maintenance. Use system like a SCADA, DCS, RTU, PLC for automation. In upcoming section, we will discuss more about it. So these are the activities commonly in the basic in our upstream sector. So basic overview of well construction and wellhead installation. This is very important part for us to very careful. This is only for the basic information. I will guide you some basic of well construction and wellhead installation in surface oil field. Okay. So first of all, we need to know about the background of oil and gas wells. Historical background. The oil and gas industry began with the first mechanically drilled oil well in Drake well in Titusville, Pennsylvania, in USA in 1859. Since then, the technologically advancements have enabled deeper drilling, offshore operations, and improved recovery techniques. Well are drilled mainly for hydrocarbon extraction. Hydrocarbon means oil and gas extraction, exploration, and reservoir management. Reservoir means where we accumulated the hydrocarbon. So this is the historical background of oil and gas industry. So basic of surface wellhead system. We are now going through the basic of surface wellhead system. A surface wellhead system is a set of equipment installed at the top of an oil or gas wells. Once we drill the oil or gas wells, we will install the equipment is called wellhead system. It's control your pressure. It does also as a gateway for the well. The surface wellhead system is like the gateway of a well, controlling the start point of the oil and gas flow from underground to the processing station. It must be strong, leak-proof, and designed to handle high pressure. low pressure, high temperature. This is based on design and construction. There are two types of wellhead system in surface. First one is conventional wellhead system. The second one is compact wellhead system or unitized wellhead system. This basically these two type of wellhead system based on design and construction. So what are the conventional wellheads and compact wellheads? We can discuss about it. Overview of surface wellhead system types. Conventional wellhead system made of separate components like a casing head, casing spool, and tubing head, tubing hanger, casing hanger, all are separately, we can separate it. So it is called conventional wellhead system. Also installed step by step during drilling and completion. During the drilling, conventional wellhead system, we will install the step by step like a casing head, casing spool, tubing head, tubing adapter, Christmas tree. There are many. This is the step-by-step installation for conventional wellhead system. Also the flexible design suitable for many well types, commonly used in onshore and shallow offshore wells. The conventional wellheads commonly used in onshore, on-land wellheads and shallow offshore wellheads. Shallow wellheads means low depth wellheads, wells in offshore. Second, compact or unitized wellhead system. This is integrated components in single unit assembly that integrates multiple wellhead function. Your casing head, spool, casing head, tubing adapter, everything will be integrated with a single unit. It is called compact wellhead system. This is the advantage is faster installation and cost saving in drilling operations. Mostly used in where time, cost, and space are critical, especially in high volume drilling. The things are compact wellhead system. If compared with rather than our conventional wellhead system, the conventional wellhead system having any maintenance requirement, any intervention requirements, you can disconnect from the which part you require. But the compact wellhead, entire wellhead system have to be nipple down for maintenance. That's the difference, and also there is a more advantage and negative also. So the conventional wellhead and compact wellheads are the major two type of wellhead system in surface wellhead. So key objective of the wellhead system. What are the key objectives of the wellhead system? First of all, you have to understand wellhead system is the backbone of oil and gas well operations. Wellhead system is the backbone of oil and gas wellhead operation. See, ensure well integrity and safety. The first, ensure well integrity and safety. The wellhead system, there are the key objectives. Maintain pressure control and fluid flow. Prevent equipment failure and costly interventions. Extend the lifespan of wellhead components. These are the objectives are for wellhead system. So the standards, international standard API specification 6A, we are following for the standard for wellhead components, wellhead and Christmas tree equipments. API 6AR is maintenance, repair, and rectification guide for use to wellhead and Christmas tree. These are the common standards we are using in API. So the foundation concept, how a well is built and wellhead is installed. It's a very important. Building a well start with the drilling a hole deep into the earth to search oil and gas. Very simple. Building a well start with a drill a hole deep into the earth to search oil and gas. We install steel pipes called casing to support the well bore to prevent collapse, stands on or any So we will protect for each casing layer to fix the cement for strength and safety. Once the production casing is set, then we will install the casing. Or also there are the kind of different type of casing. We will come to the section. After the casing installation, the final casing is the production casing. Once the production casing installed, set up properly, we will install production tubing. A similar string a pipe is run inside to carry the produced fluid to the surface. This is the responsible. This is the duty for the production tubing. Actually, the function of the casing and production tubing is very much different. The production tubing is functioning for run inside carry the produced fluids to the surface. After securing the casing and installing the tubing, we install the wellhead at the surface. Once you complete your casing and tubing, we will install the wellhead at the surface. The wellhead control pressure, support the casing and tubing, and prepare the well for production. So the very important responsibility and role and function for wellhead. The wellhead control pressure, support the casing and tubing, and prepare the well for production. So we will come to the stage one. Stage one, well, we are starting a cellar. The cellar like a pit. The pit, initially we are the drilling exploration and design part is completed and transferred for the drilling. The drilling construction team will do one first cellar around the 3 to 15 feet, one cellar. Okay, this is the typically in onshore wells, try to digging a cellar between 3 to 15 feet. Second stage, after the cellar, running conductor casing. This is calling drive pipe. The conductor casing is the first and largest diameter pipe set to in a well. This is the conductor casing. It is installed after digging the cellar and is typically 30 to 150 feet deep to provide structural support near the surface. This is provides support for the surface. So we will come to stage 2. This is stage 2. We will little detail about stage 2. The conductor casing is driven up to depth of 30 to 150 feet, around 10 to 45 meter on onshore wells until it reaches a firm formation that prevent loose surface soil from caving in. Caving in means in the cellar, the well bore is calling caving in. It may also be cemented in place to provide solid base for the next casing string, usually surface casing. So the first we will install the conductor casing, then we will come to surface casing. So we need to be strong. Our first in our casing for conductor casing, called conductor casing. So the key purpose for the conductor casing, support the wellhead. He is giving support for the wellhead. Prevent surface washout. Any washout or surface from it will prevent from surface washout. Provide return flow paths to drilling fluid. During the drilling, the conductor casing will provide you the flow path to during drilling. Start the foundation of blowout preventer BOP installation. These are the key purpose for conductor casing. So we will come to stage 3 after conductor casing. Once you install the conductor casing, you will install one adapter flange or drilling flange is welded to the conductor casing for connect the BOP preventer system to control the wellhead pressure. Why actually BOP, blowout preventer, is a safety device to entire control your pressure during your drilling. So once you install stage 1, stage 2, the conductor casing, you need to to resume your drilling, you continue your drilling for next stage of the casing, the called surface casing. So you need to control your pressure. So we need a strong foundation and strong safety device. It's called BOP. Is installed on your conductor casing. So how to install it? We will weld one temporary flange. It's calling drilling flange or adapter flange, top of your conductor casing. Then we will install your BOP. We will nipple up your BOP on your conductor casing. Then stage 4. Stage 4, surface casing string will install. Once you complete your conductor casing, you will come to stage 4 to surface casing running. So to begin a well, an initial hole drilled to the accommodate to the surface casing, which is then installed depending on the geological formation encountered, including fresh water, salt water, under potential hydrocarbon barrier zone. Multiple casing string may be run at the varying depth. This will depend on the designing. So the second casing means surface casing. Surface casing, it's drilling through your conductor casing. So the stage 4 is surface casing after conductor casing. You can see the picture, the surface casing. This is the drilling for the surface casing. You can see the yellow color is showing, your conductor casing. So now you can see stage number 5, after your surface casing, make it up surface casing. After the surface casing is run, it is cemented from the bottom to top surface because of the strengthen to providing a crucial zonal isolation. For the cementing, the purpose of cementing is providing crucial zonal isolation from Fermi anchoring the casing. To ensure the safe disconnect, a cement plug is set inside the pipe before the blowout preventer nipple down. That's the meaning of, you can see, after the casing pipe insert inside the conductor pipe, what we'll do, we need to nipple down your blowout preventer for your next operation. So how you will nipple down? You are after the surface casing running, you have to do the cementing, the cavity of in between conductor casing and surface casing. Then only you can prevent the zonal isolation. So you will do the cementing this area. What you will do this area? You will do the cementing this area for strengthen your surface casing. But once you run your surface casing, that means the hole is open. So you need to isolate. Once you isolate, then only you can nipple down your BOP, because BOP is connected here for your drilling. So you have to do one cement plug. It's calling cement plug inside the surface casing. After you make sure the pressure 0, then you nipple down your BOP section. Then you come to next stage of conductors and the surface casing cutoff. Next stage number 6. The following the cementing and the BOP removal, you nipple down the BOP. The surface casing is drained because there is a mud and a fluid, drilling fluid. You have to drain from, there's a 2 hole they put and they will drain. Then you remove the adapter flange. There was, you installed the one adapter flange above the surface casing or conductor casing. You have to remove the temporary adapter flange or drilling flange. Both the conductor pipe and surface case are precisely cut to the required elevation to ensure the final wellhead assembly with the flush with the ground surface. As per your design, the client or customer, whoever may be, they will give you the actual the requirement of the height, your wellhead equipment. Then you have to calculate your height and you cut off your both surface and conductor casing as per your specification and drawing. Then you come to the installation stage, stage 7. After cutoff, after being welded the threaded into the liner and outer surface for the surface casing. The casing head housing is pressure tested and critical. See, once you cut off stage number 6 here, you have to install your casing head. It's calling casing head housing, top of your surface casing, top of your surface casing. But your support, your surface, your casing head housings, the landing support base plate, it's calling landing plate, base plate. This plate you can give them support only top of your conductor casing. Conductor casing give you support for your entire wellhead. That's why you can connect it, you can weld it over there, or bolt over there, or clamp or whatever. As per the specification and drawing, you have to connect it here. This is, but your wellhead will stand on your surface casing. So the first component is your casing head housing installed on surface casing. Then you see the casing head housing is present. The critical step, confirm the integrity of connection to ensure the leak and paths. You have to weld it here, or any kind of system, any kind of type of casing head housing and casing head is there. So the procedure will be changed. As per the procedure, you have to make sure the integrity of the welding, integrity of the threaded, integrity of the clamp, integrity of the slides, whatever, you have to make sure the integrity. This is the stage 7. After you make sure your integrity of you installed safely and successfully your casing head housing for the wellhead, the first the base assembly. Then you will come to the stage number 8, BOP setup. Again, you have to set up your BOP for the further actions, drilling actions. So the BOP stack is nippled up on the casing head housing and subsequently pressure test. You have to do the pressure test. This test is performed by deploying a test plug in the drill string. It's a special design for the BOP integrity test. It's calling test plug. This you have to install, you have to deploy to the bowl of your casing head assembly to test the integrity for your BOP as well as your wellhead as first assembly. So this test is performed by deploying the test plug and the drilling string, seating in the casing head bowl. This is calling casing head bowl. This is the space is casing head bowl. So, and applying pressure from the surface of the elevator from the BOP sealing capabilities. So the pressure you have to give from the surface to do the pressure test to integrity of the BOP. Then stage number 9, we are bushing setup. There is the setup, temporary setup for protect your bowl surface area, seal area, surface area, to protect during the drilling or any other cementing, whatever maybe. We need to protect your equipment. So we are bushing. The component name is wear bushing. We are installing there for the protect temporarily. So the wear bushing, the number stage number 9, we are set up wear bushing. Wear bushing is run and set inside the casing head, prevent the damage to the critical internal components during drilling activities. This is you install it. Then you have to come to stage number 10, intermediate casing string running. So the surface casing you run, you install your base assembly, then you tested your BOP, you nipple up your BOP and tested your BOP integrity, then you protect your casing head assembly, then you give the green signal to the drilling will start again for next stage of your casing, the calling intermediate casing between surface casing and intermediate casing. There is a space, the space will be filled by cement again. After setting the surface casing, the next stage involved drilling a hole for the intermediate casing. This pipe is then run and cemented and consist with the surface casing practice. A cement plug is set left. The similar, we need to do the cement plug for the isolation part for the next stage. So intermediate case is running. So stage number 11, casing hanger and casing spool installation. After the intermediate casing, with the intermediate casing hanging from the rig. So you did the intermediate, you run the intermediate casing, there is no support. So what will do, you will hang by, there is isolation already you deployed by your cement plug, so there is no flow back, but you have to hang from the rig rotary table or rig platform to hang from the rig platform for your intermediate casing. Then BOP, you can pick it up from there. Then once you hanged from the rig platform, you can pick it up your BOP, and casing hanger you can set up into the casing head bowl. You can see the casing hanger installed here. This hanger is holding your intermediate casing. You can see the hanger is set up here with intermediate casing. So your surface casing, top, your bowl, casing head housing. Inside the casing head housing, we will insert your casing hanger. The many kind of casing hanger, many type of casing head housing, many kind of procedures. This is different. This is very deep sessions, but this webinar we cannot take it as all. But just the basic, I will inform you. You have to take the basic. But those who are interested, we can contact us, no problem. I will give you the more information about for our through journey. So concentrate again. So we will come to the point. Drain the hole, cut the casing, slice up, remove the drill floor, the same similar the stage. Following the drainage, the casing cut off the correct level for the similar for the surface casing. Casing spool installed, then you have to install the casing spool. This all measurement is it's as per your specification, and also for the installation procedures and how to cut, how to do the beveling. So there is many procedures are available in the international standard. So this is the intermediate casing installed here. Your casing head spool. It is calling casing head spool, casing spool. So many names are there. So once you install the casing head spool, you come to the next stage to BOP setup again for BOP nipple up top of your casing head spool. Subsequently, you have to do the pressure test for the integrity. Then the test conducted by running the test plug, similar. Okay, from the casing head bowl and casing head spool bowl, and applying the pressure from the both, similar to do the pressure test. Then you come to the stage number 13, similar. You have to do the wear bushing for protect your bowl area. Then you come to stage 14 to the production casing string running. See, first you conductor casing you run, then you come to surface casing. You top of the surface casing, you install your base assembly for wellhead. Then you run your intermediate casing. After intermediate casing, you run your casing head spool for your intermediate assembly for wellhead. Then you nipple up again for safety device for further drilling. Then you start the drilling for next casing stage is calling production casing. The production casing usually run to the total depth. Total depth means it will go to the reservoir where availability of oil and gas or hydrocarbon is called. So this is the production case running. The production casing usually run to the total depth. Required drilling and detected hole. Running the casing and cementing, it's a similar earlier casing preparation on operation. The cement plug will be left with the final stage. So again, you will do the cement plug will left there, similar to the previous stage. Then stage number 15, we will start again to the next casing hanger, because you need to hang your production casing. So you need a hanger. So you secure your production casing, you install the casing hanger, second casing hanger. We hang the production casing with a rig elevator, then pick up the BOP again, the same stage, and you install the casing hanger just like we did before. Then we will install the tubing spool. After your casing hanger, you install the casing hanger here. So you secure your production casing. Then you install your tubing spool. This is tubing head spool, tubing spool, you can turn. Okay. Then once you install the tubing spool, you have to nipple up again your BOP system. Once the production casing is in place, see, the production tubing is run. The production casing ordered reached to your reservoir. So you are ready for your tubing to lift up your hydrocarbon to the surface. So you run your production tubing inside the production casing. The tubing string is internationally not cemented. Okay, this is we are not cementing for tubing. So enabling is removal for further maintenance or workover or intervention operations. We need a removable type. That's why we will not do the cementing or anything for a tubing string inside the production tube casing. So you can see the picture. There's a tubing inside the production. There's a packer to prevent your unwanted circulation and also control your flow only to the tubing. If there is no packer, if packer is the preventing your unwanted flow, otherwise it will come to here and there, it will cause another issues. So to avoid the issue, we install the packer there to control your flow inside the tubing only. So you can see the surface packer assembly installation. After stage number 17, once you run your tubing inside the tubing production tubing inside the production casing, you run your packer. You see the packer insert here. So you run with the packer, surface packer. You run and set the downhole packer assembly. It's kind of seal inside the production casing. This stop oil and gas from ongoing anywhere except the production tubing. I told you it's an unwanted area. We will prevent we can prevent the flow path. So we will allow to enter the only tubing for carrying or hydrocarbon to the surface. This is the purpose for subsurface packer. So stage number 16, after subsurface packer installed successfully, you have to the tubing hanger makeup and installation. Once you complete your packer installation and you make sure the integrity of the packer, you pressure test the integrity of the packer, then come to the installation of tubing hanger. So why? Because you install the tubing inside the tubing production casing. So we need to make the strength of your tubing. You need to hang and make to secure your tubing. So we will install the component name is tubing hanger. This is also many kind of tubing hanger, many type of tubing hanger, many procedures are there. This is also very deep sessions. Okay, so those who are interested, no problem. I am ready. So once we will complete first this session, we will discuss about it. So the tubing hanger makeup and installation. The tubing hanger is made up on the tubing at the surface and then run into the tubing spool bowl. You can see the tubing spool. There is already we installed tubing spool here we install the tubing spool. There is a profile for your bowl for your tubing hanger. Okay, so we will install your tubing hanger. You can see the BPV, sorry. You can see the hanger here. See the profile of your inside your tubing spool bowl. Okay, so the tubing hanger made up the tubing surface. Okay, run to the tubing bowl after testing the packer. So after testing the packer only you will install your hanger. A back pressure valve. This is calling back pressure valve BPV. For what? Back pressure valve to install the hanger provide well control, because you have to nipple down your BOP to ensure the flow control. So you can install the back pressure valve to protect your backflow from the reservoir or from the underground. So you can install one back pressure valve. There is a profile inside the hanger. You can see this is your tubing hanger. They given the profile for BPV for inside the tubing hanger. So the tubing hanger is a functioning both to be hanging your tubing as well as protect your backflow from the underground by BPV. So the final stage, you did your tubing head spool. You have to come to this is calling tubing head adapter, and this is your Christmas tree, express tree, production tree. So many names are there. Flow control tree. So the Christmas tree, which is also called flow assembly, is how we control what come out of the well. This is the Christmas tree. It has a seal flange or tubing head adapter. This is the tubing head adapter, is a seal flange. And different valves or backup and choke for safety. It has automatic valves to shut in things down if there's a problem. We connect to the piece of pipe called flow lines. It's all connected with your Christmas tree. So the Christmas tree, you can see the picture. The Christmas tree is a group of valves. Okay, this is flow control valves. This is calling pressure control equipment. The pressure control equipment from the surface. So after checking for leaks, the well is ready for the testing. How much can produce? Everything you will get the information from the Christmas tree. Christmas tree is connected to the tubing. It is not connected to the casing. It is connected to the tubing. The connection is here. There is an adapter they given. It is calling tubing head adapter THA. This adapter, above the adapter, you will install this Christmas tree. It's calling final assembly. So your intermediate assembly, your final assembly is here. Adapter with the Christmas tree. This is the stage number 19. So you construct journey from the depth to the surface. Once you complete your Christmas tree installation, that means completion of your wellheads, you construct your wellhead and wellhead along. So you can see the surface completion equipment overview. Wellhead. Wellhead is the primary structure and pressure containing assembly installed at the surface of an oil or gas well. It's connect the casing and tubing to the surface and serve as a foundation of the Christmas tree. But Christmas tree, you can see the Christmas tree is an assembly of valves, group of valves, spools and fittings installed on the top of the tubing head adapter or tubing head to control and regulate the flow of oil and gas or water from the well. This is the function. You can see the Christmas tree. This is your wellhead. Wellhead, there is a sections. There's a base, section A, section B, section C. If more section after the chances depend on your design and geological survey. So this is the Christmas tree. There's a valves, the calling different name, master valves, upper master, lower master. You can see the adapter. This is a choke valve for flow regulating, and this is the primary wing valves to control the flow for injection, production, whatever. This is your tree cap for intervention for maintenance. This is your swab valve for maintenance activities, for silk line interventions, wire line interventions, coil tubing interventions. This is allowed to them for the tree cap and the swab valve. This kill wing valve, you know, any emergency, any urgency, you can kill the well through here to stimulation, acid stimulation. These are the wells calling kill wing valve. This is production wing valve or injection wing valve. This is a primary wing valve. These are the Christmas tree overview, the equipment. So now we are coming to the integrity. Importance. Now we completed the well construction and wellhead construction, well construction and wellhead installation. The next we are coming to the wellhead integrity and maintenance phase. Importance of wellhead integrity and maintenance. See, wellhead integrity and maintenance is a powerful risk management tool. It's a very important part. What is the scope? To ensure wellhead integrity and safe operations, routine maintenance is crucial. You have to conduct a routine maintenance. It's scheduled and planned. This includes inspecting for leaks, verifying the annulus pressure, testing the functionality of safety valves. It's like a SC, SSSV, subsurface controlled subsurface safety valves, SSV, surface safety valves, and seals, lubricating moving components, greasing, maintaining the condition of lockdown screws, alignment pins, choke actuators, hangers is essential to prevent failures. All maintenance activities must be performed with strict HSE compliances. So this is the scope of work, wellhead integrity and maintenance. Okay. This is also very deep sessions are there, but now I'm going through the basics only. You have to understand what are the basics are there. So the importance of integrity and maintenance, prevent equipment failure and safety hazards. The first one, first important point. Also extend the life cycle of wellhead components. Ensure regulatory compliances, regulatory compliance and operational efficiency. Reduce the downtime and the maintenance cost. This is very, very important for reduce the downtime and the maintenance cost. These are the core importance of integrity and maintenance. The key objectives: safety, reliability, performance. Prevent leaks, blowouts, pressure failures, consistent operation of wellhead components, maintain optimal flow and pressure control. These are the key objectives for the wellhead integrity and maintenance. You can see the safety, always safety first. Okay, protecting the people, environment, and the equipment. Ensure and approved PTW, permit to work system, is in place before commencing any corrective or preventive jobs. Conduct a gas test upon arrival at the well site before maintenance truck entry. This is very important. If any new engineers for upstream, those who are complete their petroleum engineering, they know. But for the mechanical engineers or instrument engineers, maybe they are not familiar with these subjects. But please concentrate this session. This is one of the safety parts for the permit to work system. It's a legal documents. And also for the gas testing, the authority for your authority for empowerment for entire work duration for any oil and gas, or especially in oil field upstream operations. Erect varying signs and designated emergency assembly points. You have to erect to the people, those who are accompanied with you or those who are along with you for the performing the job. They should know the assembly points. Ensure all crew members wear PPE, personal protective equipment, and activate your continuous H2S, your personal H2S monitors in H2S area or any area. conduct effective toolbox talk. You have to conduct toolbox talk. Toolbox talk means safety meetings, like your regular activities, what kind of activities you are going to do, what are the hazards, how to eliminate it, what is the control measure you have, what is the recovery measure you have provide, what are the emergency responses. These are the things we have to discuss before you are commencing a new job at the field. This is called toolbox talk. A toolbox talk should be effective. People should understand. There is no barrier for the language. You can use any language or any method of communications. Then isolate the electrical supply for pumping wells before maintenance. Any pumping or electrical interfaces, you have to isolate. Even instrument interfaces, you have to disconnect it. This is your responsibility for doing wellhead and integrity and maintenance. Ensure all required resources and material are available on site. It's a very important part for during your entire maintenance. These are the general safety precautions. So we will come to the point for the classification of maintenance. See, the wellhead maintenance, we have a three type of maintenance. First line maintenance, this is routine checks, lubrications, minor adjustments and minor corrective actions will attend during the preventive or maintenance. Scheduled maintenance. Second line maintenance. The first is first line maintenance. There's a routine maintenance, routine checks, lubrications and minor adjustments is a first line maintenance. The second line maintenance, component replacement. If any component is failure, we have to replace. The replacing procedure is a very deep procedures are there. We have a well control. We have a controlled by International Well Control Forum. So we need to comply with their regulations. So second line maintenance is a very critical maintenance. So the scheduled and plan is must be done before your second line maintenance. So component replacement and performance testing, pressure testing, hydro testing, or any pneumatic testing, whatever. So address major observation during first line maintenance. This is the important part. The first line maintenance, your routine checks and lubrication during time, whatever major concern you have to report to the second line maintenance. So we will address that for the second line maintenance. Then ad hoc maintenance. What is ad hoc maintenance? The ad hoc maintenance in wellhead system refer to unscheduled jobs, immediate repair, or servicing performance in the response to the unexpected failure, leaks, or operational issues in the wellhead system. This is unplanned jobs. This is called ad hoc maintenance and supporting to other department, supporting to your department, supporting to your system, supporting to other system related to the wellhead. This is called ad hoc maintenance. So this is the three classification mainly in wellhead integrity and maintenance. So first line maintenance, what are the activities? The first line maintenance, you can see the key activities only, but the deep is different. The activities, basically visual inspection, periodic inspection of wellhead components, then lubrication and tightening of critical parts, lubrication for the moving parts, function testing of the valves. You have to do the function test for all valves, chokes and actuators. Then pressure testing of leak detection. You have to do the pressure testing for the leak detection. Then cleaning and refurbishment for the seals, gaskets. Cleaning of wellhead equipment, entire equipment you have to clean. Report and documents is a very important part. You have to report and document all the collective observations and suggestions and the detail of the system. You have to report and document. These are the main activities, key activities for first line maintenance. The second line maintenance, key activities, Christmas tree valve replacement is a major activity. Christmas tree change out. You need to change out any Christmas tree. The very major activities. Tubing head adapter replacement. threaded cross replacement, BPV and 2H equal lubricator running and pulling, casing walls, side of walls replacements, VR plug means wall removal plug, lubricator running and pulling. This is for VR plug using for the casing wall replacements, tubing hanger and seal replacement, flange gasket failure, annulus investigations, cavity tests, casing tubing hanger seal tests, lockdowns and alignment pin leak, SSSV subsurface safety valve open close function tests. These are the key activities all under fall second line maintenance. This is also deep session there, but I am giving you just the basic of key activities. Then ad hoc maintenance. What are the activities there? Addressing sudden leak or passing. You have to address sudden leak or passing. On-call response from production operational requirements. Critical support for workover or well intervention activities. Emergency replacement or damaged valves or seals or whatever components. Pressure testing after unplanned shutdown or repair. Temporary installation for pressure control devices. Any pressure control devices need to temporary installation. This all coming under ad hoc maintenance. So these are the three main part of your maintenance: first line maintenance, second line maintenance, and ad hoc maintenance. Now we will come to the upstream flow basics. See, once you done your drilling, after completion of your wellhead and ready to produce your hydrocarbon, then we need to hand over to the production. Then we start for the production upstream upstream operations. Upstream operations are there are two level. One is exploration, another is production. So we exploration stage almost over. Then we are going to journey from wellhead to the gathering station. Gathering station means the processing station. The processing station. The first processing stage only. The crude oil coming to the station, gas coming to the station. The first process will done by upstream operation. The second stage will do by downstream only. The marketing, refining, purifying petrochemicals, petrochemical products, manufacturing. These are all under downstream operation. But we are here in upstream operation. We will do the first line production process only. We will separate the oil, gas, and water. Then we will transport through the pipeline. The pipeline controlled and storage are controlled by midstream. The midstream, there is a transporting facility and storage facility. Then from midstream to downstream, the downstream there is the refineries, petrochemicals, so on so. So they will. So we can also today we will small journey. We can start with one wellhead to one gathering station. So ready to journey with me. We are going to from wellhead to gathering station. First we can go to the upstream operation. What is the upstream operation? You see the upstream operations are the heartbeat of the oil field. Wellheads are the backbone of the oil field. Upstream are the heartbeat of the oil field, driving exploration and production of energy resources. See, this is upstream operation. Don't forget, upstream operations are heartbeat of the oil field. And the wellhead is the backbone of the oil field. So upstream operations. Oil field upstream operations are first into the process and activities involved in the exploration, drilling, and production of hydrocarbon, oil and gas from underground reservoir. It is the first phase of the petroleum industry. Upstream operation is the first phase of petroleum industry. We already discussed. So we can journey from wellhead to gathering station. The surface flow and control, simple understanding for the upstream beginners. Those who are attending this training, these sessions, please carefully understand the overview of the journey from wellhead to group gathering station. See, overview, upstream operations surface flow path. Number 2, overview, upstream operations control system flow. So once journey, we can see the wellhead. Then after wellhead give to the hydrocarbon through flow line connected with manifold. Manifold is controlling and maintaining with different many wellheads with a single unit. Then manifold to connect to the group gathering station. This is our journey. So we will come to the wellhead to gathering station, flow movement and control management. See, surface flow path is very important from the wellhead, flow line to manifold to group gathering station. This is the surface flow path for upstream operation. Upstream control flow. Once it is coming from wellhead to flow line, through flow line to manifold, from manifold to gathering station, we need to control the flow. There is a system for the control flow, field devices, PLC and RTU, SCADA, DCS to CCR, Central Control Room. We will come to the next section in detail for control flow and flow path. There are another control for the speed load your equipment inside the gathering station, equipment speed, load control. There's a VFDs connected with the SCADA and DCS. All the control systems are inside the upstream operation. So we will come to the deep upstream operation, the surface flow path, wellhead. What is the function of wellhead? Control the flow of oil or gas safely from the underground reservoir to the surface. This is the function of wellhead. Then connected the flow line to wellhead. What is the function of flow line? A pipeline that carry the produced fluid, oil and gas from the wellhead to the next collection point. What is the next collection point? The manifold. The manifold is called next collection point. The manifold means a gathering point where flow from multiple wells are combined, controlled, and directed for processing. This is called manifold. From manifold, where is going to group gathering station. The gathering station, a facility where fluids are separated, measured, and prepared for further treatment or transport. It is called gathering station. So we will come to the next point. You can see the flow path, surface flow path, wellhead, then flow line to manifold to group gathering station. Then you can see the overview. You can see the picture, the drawing, how to coming. You can see the wellhead. There are many wellheads. See many wellheads coming to the gathering station, the stages here. There are many equipments located there. Okay, separators, compressors, storage tanks. The many equipments are located over there. This is upstream flow path. Then upstream control flow, field devices like a sensor, transmitters. What's the function? The sensors, transmitters collect real-time data from the field equipment, field functions, to give to PLC or RTU. PLC means programmable logic controller, or RTU means a remote thermal unit. This is locally processing signal and send them forward to the next system, like a software is SCADA, the DCS, we can call DCS SCADA together. SCADA DCS is a supervisory control and distributed control system. See, the field devices taking data from the field equipments and field resources, giving data to the RTU or PLC or RTU, whatever. So RTU taking this data and signal properly, and the RTU cannot visible. So RTU is only saving the data inside the RTU unit. So RTU is a device as a hardware. Flow device is also hardware, but the SCADA is a software. So the RTU, whatever the RTU is collecting the data from the field, the SCADA can give you the visibility. You can see all the parameters and the readings and rates in the screen. So you will get the accurate value, accurate parameters, accurate structure, accurate picture for accurate detail in the screen. So you can monitor properly, you can control properly. This is calling SCADA, the DCS. Is located in the central control room. This SCADA DCS is located in central control room. The DCS, the importance, the SCADA is taking signals from the remote field monitoring base, all you collecting from the field, it's giving to the DCS. The DCS, the importance, DCS itself can manage complex process. At a time, the complex different process can control with the automation system with the SCADA. This is the control flow in the upstream operation. So field devices collecting the real-time data, passing through the RTU. RTU will monitor the data, then the process the signal to give to SCADA softwares. The SCADA software and DCS is a multiple complex. They work together to monitor the control the system and controlled by automation. This is calling SCADA DCS. This is calling control flow upstream operations. Then we will come to the point here. You can see the field devices collecting signals, data, real-time data, giving to RTU. RTU is the unit, the device, receive the signals and send from devices, all connected devices, all the signals and readings and parameters come to the RTU. RTU will give the signals to SCADA, display and control the field operations from the distance, because SCADA is you can control from any distance, because you know our wellheads are located in far from your control room, because gathering station will located and wellhead and gathering station in between quite far. So we can control from far by SCADA. So SCADA will give you the visual monitoring diagram, like a picture, a screen. So you can see the display to control your operation. So the DCS and CCR, the SCADA DCS is together, but the CCR will central control room. They will manage process control and plant automation. Entire plant and entire upstream operations controlled from the CCR. This is the control flow. Then you come to the speed flow. You can see the upstream oil and gas operations, speed and load control is essential for optimal equipment performance and maintaining safe production rate. So the speed control is very important part of in our upstream operations. Control flow for group gathering equipments, station equipments. You can see the flow. Field equipments like a separator, heater, pumps, compressor, valves, sensors, all controlled by RTU. or PLC and data collection. They will collect the data for your equipment, give to SCADA. To SCADA will remote monitoring and supervisory control by SCADA. Then SCADA will connect it with the DCS system. So different multiple activities can control by single DCS. So the DCS is a plant-wide control, process optimization, alarms, everything controlled by DCS based on SCADA informations. And the SCADA will depend on the receiving the data from PLC and RTU. The PLC and RTU will collect the data from the real-time data from the equipment sensors and the valves and whatever installed there, the devices. Then the all DCS controlled by central control room, operational monitor and control, everything, or your everything for your upstream operation. CCR oversees the entire field operation for safe and efficient production. This is the central control room function. So upstream operation set up by the flow setup, you can see purpose. To separate the mixture product produced from the well. You know the well is the drilled fluid coming from the reservoir to the surface with the mixer, compressing oil, gas, water, all mixer type is coming to this, calling crude oil. This crude will come to the or gas or crude oil, whatever, and into the individual component for further processing or disposal. So key separation stage, we need to separate it. So coming together to a mixer produced. So this product we need to separate it. Separate in the processing station, that is calling group gathering station. There are many equipments, the control system to processing for the first stage, processing for your oil and gas. So the key separation stage, first wellhead output. The wellhead produce a combined stream of oil, gas, water, and solids. This is the first output from the wellhead. Second, primary separation. This wellhead output coming to the separation stage through your flow line connected with the manifold and coming to the group gathering station. Group gathering station have a first stage, your processing unit. So the primary separation, utilize the separator to divide well stream into the gas and liquid phases. Gas direct to the gas processing unit, while the liquid process to the next stage. This is the primary separation. Gas will go to the detected gas processing unit, and next remaining liquid will go to the next stage preparation, secondary separation. So secondary separation further separate the liquid phase into the oil and water. The oil sent to the refining for storage, and water is treated or reused for the disposal. This is the secondary separation in the oil and gas sector. So number 4, the solids handling. There are solids like remove the sand, other solid particles, for prevent equipment, and maintain flow efficiency. We need to control the solid. Otherwise, you cannot get the proper optimization production. So we have to control for the flow efficiency. We need to control your solid handling properly. So these are the purpose for upstream separation. Upstream. So purpose of upstream separation. So can see the end product of further. You did your upstream separation. What are the end products, your output? Oil, gas, water, solids. Oil sent to refinery for processing into various petroleum products. Gas processed and transported for use for fuel or feedstock. Water treated and either reused for operational and disposal of the compliance with the environmental regulations. Solids collected and managed according to safety and environmental standards. This is the end products, the final stage of upstream separation. So these are the content today we discussed about for the wellhead and well construction and wellhead installation, maintenance and integrity test management. Then we come to the upstream operations, the various type of different type of processing stages, and we discuss about the control flow. So the new engineers, those who are basically focusing on upstream operation, there are many job opportunities in upstream sector, onshore and offshore. If you study well about this content, like a wellhead and upstream operations, if your proper journey from wellhead to gathering station, you can get many opportunities. Like you can see the opportunities, jobs and privileges. Jobs in wellhead and upstream operations are important role in oil and gas production. These jobs involves handling equipment that safely controls and the flow of oil and gas from the wellhead to the processing stations. Many of these roles, especially in remote areas, onshore and offshore, offshore are offered as a rotational job. For example, 28 days working followed by 28 days off, 35 days working followed by 35 days off, 70 to 28. This system allows you employee to have a long break to relax and spend time with your family life while enjoying good career growth and global job opportunities. This is compared with other sector. The upstream sector privilege is a little different. You can see the privilege include high earning potential with overtime facilities and rotational benefits. Most of the companies are giving free food accommodation. This is the regulation of oil field. Free food accommodation and free accommodation and food at site and camp facilities free. Also travel benefits for rotation free. Skill development and global job opportunities, the privileges, exposure to advanced technology and safety system. You have many advanced technology and safety system you can learn in upstream operations. These are the privileges in upstream operations. So you see the opportunities. Once you see the wellhead and upstream operations, multi-position readiness in one training. If you got a good training for wellhead and upstream operation. It's a single training. You will get a multi-position in the oil and gas sector globally. Field service engineer, field service technician, wellhead engineer, installation engineer, wellhead integrity supervisor, wellhead operator, wellhead maintenance supervisor, field operator, wellhead and Christmas tree, wellhead and Christmas tree engineer, wellhead and Christmas tree supervisor, production operation technician. These are the chances are there, opportunities are there in upstream operations. Once you completed your full knowledge about wellhead and upstream operations and high privilege opportunity. So come to the point, our training program. See, we are RASE Technical Training Center in Chennai, located in India. Our training programs and candidate benefits, multiple position in multiple sector, we are doing training. We are special training only we are giving. Our premium training are wellhead and pressure control equipment, installation, completion, maintenance, and upstream operation. These are the 4 modules we are concentrating during wellhead and pressure control equipment session. So you can see our training program for candidate benefit. Why join this training? Master the complete life cycle of wellhead system through our industry 11 curriculum. Module 1 installation, Module 2 completion, Module 3 maintenance, Module 4 upstream operation and field automation. Our training methodology: 3D printout demo equipments for realistic hands-on experience, concept to field application training, interactive case studies and question and answers in sessions, career guiding, mentorship and placement assistance. Who can join with us? Engineering graduates, diploma holders from mechanical, petroleum, chemical, petrochemical, instrumentations. Those who are completed from Indian Technical Institute, ITI, trade holders and industry professionals, or any other country, if you are completed their technical training from Technical Education Board, from the government, you can join with us for this training for wellhead and pressure control equipment. And we are conducting other trainings. The major training for rotating equipment. This is the whole sector you can use for this rotating equipment installation and maintenance, static equipment installation and maintenance. Number 3, detailed design engineering, mechanical rotating and package equipment. These 3 trainings we are giving, and also subsidiary for rotating equipment. With there are many subsidiary training related to rotating, like laser shaft alignment, like condition monitoring, vibration analyzing, reverse dial. These are the alternative you can use for the subsidiary subjects. You can specialize with the rotating equipment sessions. So we have a special trainers for the rotating equipment and static equipment, and especially for detailed design engineering. Those who are completing their degree or diploma in mechanical engineering, they can come to join with us for detailed designing also. So our other specialized training, this is the short time. All our trainings are short time training program only. So contact with us. This is on our website is there, mentioned over here. So the session now I am concluding. So any question or answer, you can type it, and our admin will contact us. We will answer you. But very deep question, if long question, we can mail you through mail or any other communication method we can use. But short questions or any doubts regarding training program, regarding our benefits for job opportunities, or any wellhead systems, you can ask me. Free feel to ask me any questions. Then we can wind up our session and our webinar successfully today.
Yes, Mr. BINU, thanks for the wonderful session. Just before getting into the session, we have some question in the chat box. Guys, just if you have any doubts or any queries, just give your thoughts in our chat box that I can able to address. Mr. BINU, there is a question from Mr. Noor Alam. He is asking about artwork is allowed to cut the adapter flange.
No, cut adapter flange is not allowed. Adapter flange means for the drilling flange we can cut, because this is temporary arrangement for nipple up your first stage of BOP. So we can supposed to be, we need to remove from the conductor casing. Okay. There are 2 adapter flange. One adapter is the final stage of Christmas tree, our wellhead system. It is related to the wellhead system. The adapter of flange or drilling flange is related to well construction. The well construction adapter flange is the installed on top of conductor casing. We should be removed during your nest casing stage.
Okay. So the next questions will be about API 6A is covering all this process of drilling and arrangements.
No, no, no. It is special for only wellhead and Christmas tree equipment. In drilling, tubing, casing, and different specification, and there are many specifications and standards and practice are there. It's a different. So individual section, they have a individual procedures, individual specifications. So, but for the general, for the wellhead and the Christmas tree, we have all equipments and components under fall API 6A.
Okay, so next question that what is the average depth of production casing, or it is
No,
different in different countries or areas?
Yes. This is depend on your geological survey. Based on your geological or seismic survey, the well designed, see the well life cycle, there are first stage of exploration stage, second stage well design and planning, third stage drilling. So the well exploration stage, we will make sure there is a reservoir, there is an oil. So confirm there is a reservoir oil, the reservoir have a oil or gas or hydrocarbon presence. Then they decided to the survey. So the exploration stage, they will do the survey. Once make the survey, geological survey or seismic survey, there are many kind of survey. The survey result, they find the depth or reservoir capacity or the area zone and everything. They will confirm it through the survey. After the survey, the survey reports given to the designers, well designers, and they will do the planning and designing. The designers will plan based on the geological survey. So we cannot give you the standard depth or standard in the international any production casing or any casing. This depend on the based on their designing, based on geological survey, and different country, different depth, different dia, different design.
Okay, so next question will be about normally how much pressure will be there in the well, which is naturally.
Okay, there are the minimum 2000 psi to 20,000 psi. The high pressure consider is above. We are normal pressure. The low pressure is we are calling below 1000 psi is the normal pressure. But the pressure rating, if the classification for the wellheads, there are 2K, that means 2000 psi. There are 5K, there's 5000 psi. Then 10K, the high pressure, 10,000 psi, and 15K and 20K. Up to 20K is the maximum.
Okay, thanks a lot. And normally that what is the construction of material is used for Christmas tree?
There are API 6A. There are as per the designing and planning, they will decide for the material standards, qualities, material elements, whatever. There are alloy steel, there are stainless steel 316L or alloy steel 625. This is all based on design and this design and geological survey. We cannot say the standard.
Okay, so next question will be that which wall do we close to test tubing integrity to identify the holes in the tubings?
One more.
Which wall do we close to test tubing integrity to identify holes in the tubing while the pump is producing as well?
Which valve?
Yeah.
This question for the subsurface wall or surface wall? First of all, we need to.
Yeah, Mr. Henry Dawood, could you please repeat your question?
surface valve or subsurface valve. There are two kinds of valves.
Mr. Henry, if you're here, just shoot your question as a proper manner. He's asking about in the Christmas tree.
Yeah, okay. Christmas tree, there is a master valve. Lower master valve is controlling your production.
Okay, thanks a lot. And I hope, is there any doubts, guys? Just
I will
put your-
clear you. I will clear him again. The lower master is controlled by the pressure from the underground pressure. But the production for production stage, there are another valve is calling production wing valve. The production wing valve can prevent the flow, control the flow. These are the function. Along with the production flowing valve, there is a regulating system connected with the choke valve. There are two kind of choke valve we are installing in Wellhead. There is a fixed choke valve, like a positive choke valve, and adjustable choke valve. These are the controlling system for the production. Okay, carry on.
Okay, so we are, I think we don't have any technical questions as of now. So guys, you are asking about the materials and about the heat certifications and all. So unfortunately, we are not planning to issue any certifications for these sessions, but in future we are going to plan it for that. And about the material, yes, we will be sending you a material by emails. About pig launching and receiving steps, it is not a right place to ask this question. I hope there is no any commentable question now. Okay, so we will conclude the sessions now. I really thank you very much, Mr. BINU, for that highly informative and engaging session. Your deep insights into the surface wellhead systems and upstream operations have added immense values, especially for those looking to build or grow their careers in the oil and gas industry. We truly appreciate the time, efforts, and expertise you shared with us today. And to all of our participants, thank you for joining us and for your active engagement throughout the session. We hope this webinar has given you a clear understanding of fundamentals and real-world applications of upstream operations. So we will be sharing these sessions, we will be sharing these recorded sessions in our, we will be uploading in our YouTube channel. You can review this in our YouTube channel also. And please stay connected with RASE Technical Training Center for the updates on the upcoming training programs and the webinars and the certification courses. So until next time, stay safe, stay curious, and keep learning. Thank you all, everyone. Thank you once again, and have a great day. Go ahead. Good luck.
Thank you, Prakash. Thank you, everyone. Thank you. Good night.
Admin, could you please stop the recording?